Alright, in this video we're going to look at one other probability situation, and that the word you usually see that shows up in problems of this type is the word and, or it could be the word then. What we're going to really look at is what happens when we select two things, or three, but more than one. There's more than one thing that's happening, and they're consecutive, one after the other. Before we did probability situations where you're just taking one thing out and it may be able to be this option or another option, and anytime you heard the word or, it usually meant we're adding probabilities together. Well, if you hear the word and, it means we're probably going to be multiplying. Now, let's take a look at how we'd set this up. Let's assume we have a bucket, and it has 10 red tennis balls, 5 green tennis balls, and 8 orange tennis balls. It's just got a mixture of different stuff in there, all mixed together, and you were to randomly select 2 of those out. What's the probability that the first one's red and then the second one is green without putting the red one back first? After we drew it out first, we didn't put it back in. We just kept it and then drew from the remaining pile. So this is kind of a complicated situation. There's a few things we have to interpret along the way. Let's start by looking at seeing how many red tennis balls we had to begin with. There were 10. 10 red ones, and the total in the bucket was 10 plus 5, which is 15, plus 8, which is 23. So I have a 10 in 23 chance of drawing a red one the first time. Now if I keep that red one, I'm going to multiply here because I'm doing one thing after the other. They are totally dependent upon each other. 10 out of 23, I'm going to multiply that by my probability of getting a green one the second time around. Now how many green ones are still in the bucket after I took one out, took the one red one out? Well, there's still 5 there. But how many total do I have? Well, now my total went from 23 down to 22 because I didn't replace that red one that was there. So I have a 5 in 22 chance of getting a green one. Now if I multiply those straight across, I'm going to get some pretty big numbers. And I don't want to take a lot of time here to figure out decimals. That's something you can handle on the calculator. What I want you to see is, well, we would multiply 10 times 5, which gives you 50, and 23 times 22, and that's not something I'd expect you to be able to do in your head. We're going to get some kind of big number, and we could figure out what that means as a decimal. I'm more concerned with, can you set it up based on what you want to happen first and then what happens second? And we're multiplying them because the second one depends on what happened during the first one. Now let's take a look at this second problem. This is going from the same scenario. We're going to start right from the very beginning. Okay, so we've got this situation right here. We're going back to the start, so we're kind of pretending we didn't do number 1 yet. And it says, what's the probability of drawing 2 orange ones in a row, but we replace the first one after we get it? So in other words, I reach into the bucket, I grab out a tennis ball, oh good, it's orange. I put it back in, shake it back up and mix it, reach in again, and pull out another one that's orange, randomly. Okay, what's the probability that that happens? So to do this, let's take a look at the orange. We have 8 of those out of a total of 23. Okay. Now, since we put that, there we go right there, I'm going to multiply. Since we put that one back in and replaced it, the next time around it's kind of like we started over, and we still have 8 orange ones to pick from out of 23. Notice in this problem, nothing changed on the bottom or the top. Sometimes it's that easy. Up on this problem up here, by the time we get to the second one, the top changed because we were looking for a completely different color. The bottom changed because we already had one removed, and so we had a smaller total. So they look very different, even though they're kind of talking about the same situation. Now on top here, that one I can handle, that's 64. But on the bottom, 23 times 23, I don't know what that is off the top of my head, and that's really not the point here. You can handle that on a calculator. What I'm more worried about is, can we recognize when to, for example, not change anything in this case, but in this case, over here, both of those numbers were different on the second try, but it had to do with what was being asked. And this part right here is key. That's just a little intro into some other types of probability problems. Watch for this word, or the word then. Basically, you have to recognize that 2 or 3 or 4 things are happening one after the other. Those are called dependent cases. Whereas before we just had one card drawn out of a deck, and it could be this or this, it had different options, but only one thing was happening. Here, there's more than one thing happening in a row, and that becomes much more restrictive, and you're going to get smaller and smaller probabilities for the most part.